Hello, good evening everyone. I'm Vivek Gupta and I represent Benison Technologies. And I'm here to talk about the suggestions to enhance DPDK to enable the migration of various user space applications to DPDK environment itself. Right? So before talking about this, I would like to give some context on from where we are coming from, why we are talking about this. Right? So we as a Benison Technologies, right, we work with a lot of customers and they want to migrate their existing user space networking applications to DPDK or VPP, right? And at the same time, they many times they want to write new applications, but the key context is they want to reuse the open source existing applications and see that how they can get better performance. And when we use them, right, we face a lot of issues or a lot of challenges in doing that. So based on that, in the last DPDK summit, I talked about what challenges we faced. And now I want to talk about some solutions which can probably help. But before we talk, we'll give some more context about the problem because we analyze it from different angles, see what can happen, and then we will move on to the next part of it. Okay. So as part of the agenda, we'll first talk about the problem statement, that what we see as a problem here, how we can, what is needed and what is really impacting the things, right? Then we'll also talk about what are the needs of various user space networking applications and also try to classify them into various categories. Then we try to also suggest some enhancements. And only thing is all these enhancements are not something which is groundbreaking or any different, something new. These are the things which already exist. The only thing is we're trying to bring in a framework together so that it can be available for applications to do things, right? And what can be the possible impact? And some of these here are the techniques which are being used in different environments. So for example, EVPFs are using, in some cases VPP is using, in some cases different technologies are using this, and we try to see if all of this can come together as a framework. Okay. So we'll talk about the problem statement first, right? So as we all have been seeing, right, and there have been a lot of improvements in the CPU technologies, IO technologies, memory technologies, right? And the throughputs have increased. Like everybody here right now is talking of 100 gig plus of the things, right? But the sad part is, or the issue we see is that although at IO level we are able to make so much of improvements, but at a user space networking application levels, these benefits are not visible. Right? Many of these applications are not able to utilize the benefit of such things. And in a few moments, I will show that as an example as well. Right? So the intention is that the benefits which have been arrived out of these improvements in the infrastructure, that should be made visible to the user space frameworks as well. Right? So this is another view which I want to bring out. The DPDK, we claim to be user space networking application, framework, right? But actually, when it started and so far when it is going, it basically provides frameworks to run the applications or the systems which are traditionally run as part of the Linux kernel. So for example, routing, switching, forwarding, IPsec, or different cryptos, right? They were typically run in the kernel and not in the user space. And the improvements have been done to migrate these to user space. But the applications which were running in the user space, they have remained as such. They have not been improved, or the frameworks to be improved where they can utilize the benefits of these. Now, I can't say that nothing has been improved. A lot of things have been done because of which the improvements have happened. But the gap is still very, very high. Right? And the other part is, if you are writing the applications from scratch, right, you can always write it the way you want it in a different way, right? But if you have to migrate the applications, right, that's where the challenges come, where you cannot rewrite the whole stuff again, right? Or you want to reuse as much as things are available and see that your applications start from running on the new framework, right? And these applications, they have been using kernel for their means, and the kernel is getting developed from almost 91 or something. So it's a long time with a lot of features have been added, a lot of frameworks have been added, a lot of improvements have been done, and a lot of applications have been written. And yeah, we don't have to worry about all the things also. So, but they can always be choose what all things are important and make sure that they are happening. Right. So just to give an example, right, with DPDK and VPP, as again I said, we can pass traffic at a very high rate. But when we talk about web servers, I think today morning we had a session where we're talking about the Nginx and other web servers. But not many web server deployments are there which are using DPDK TCP stack or VPP TCP stack, right? And that can really help in doing that. So many web servers are there which can be scaled or improved in the throughput which is there. Similarly, the proxy servers. Proxy servers are the ones which are for security applications, that is the key thing, where they terminate one connection, DoD packet inspection, and then forward the packets out. Now, they are also running in the user space, and they become a huge bottleneck. But if we solve these issues and provide the right framework, the applications can become much, much better, and the security can improve to a great extent. Similarly, let's say we can consider even video streaming servers, you can consider file servers. All these places are where the DPDK, VPP frameworks can come in and can also provide a huge amount of performance benefits. Now, I'll give one very simple example, right? Can take any PC which has a 10 gig port. I mean, we have been talking about 100 gigs. UPS, let's talk about just a 10 gig port. Now, if I want to pass traffic to it through 10 gig port, it will work. I mean, you will get a line rate, right? Just on a simple PC, right? Now, moment you want to run IPsec, yeah, if you're running VPP or something, you can get line rate. If you're not running VPP, DPDK, you can get around 6-7 gigs, which is also fine. The moment you start running SSL VPN applications, let's some examples like OpenVPNs or SSL VPNs, the throughput will go down to 2 Gbps. Okay. Now, that's a huge, huge gap. Now, these applications, like most of our applications which are running, right, or we are using SSL VPN is the most common application being used across by all of us. Most of us do a remote work, and many of the VPN gateways, they kind of use this OpenVPN or the soft ether VPN as a VPN gateway technology, right? Now, similarly, so that's why if we use DPDK, VPP, provide a basic framework which can provide a holistic view of the full application, it can really increase the overall throughput of the system, right? So based on that, I would like to talk about some of the key requirements of our customers, right? So as I said sometime before, that the customers, they want to migrate the current applications to DPDK/VPP environment. Now they have been using there are two cases here. One is they are using standard Linux-based applications and then to migrate, or in some cases there are existing open source applications and they want to move them, right? And the time to market challenges don't allow you to write everything again, right? So that's where you get into challenging situations that how to make it happen, and we do end up providing solutions to those, but many times those are not very appropriate and the correct solutions. Much better solutions can exist if there's a right framework which happens, right? Similarly, as we know, the 5G is coming, is already there, and a lot of other, the bandwidth at the edge is increasing a lot. So the devices which are at the edge, their bandwidth processing requirements are increasing, right? And at the time there, if we make a better framework, those devices can be managed with the reduced cost, and that can help a lot overall to increase the throughput and the processing capabilities of those edge devices. Okay. So with this in mind, we'll talk about a bit about what are the requirements of the user space apps. And to do that, first we'll classify how various applications or the various category of applications which exist in the networking and security space. And it may be some more, but this is what I have tried to capture the most, right? So many of the applications are like high throughput IO driven TCP UDP applications, where they want to capture, transmit a lot of data. They can be like a deep packet based, inspection based applications. So they can be like cloud access security brokers or the proxies which have to do it. And then there can be a lot of AI ML driven applications to things again. And in most of these, the issue is that the packets come encrypted. Like, and we were all, like in the morning, we were talking about that as well, right? So if they're coming encrypted, and if there are SSL VPN based encrypted packets, you need to terminate the packets, you need to decrypt the packets, do a deep packet inspections, and then forward it out, right? So everything can really become very slow if it happens like that. So although a lot of improvements are happening, but again, I would say that to the user applications, the benefits are not reaching. Yeah, so it's the same thing. Correct. Now let's look at, so first we looked at the way classification of applications, what those applications do, and now let's look at what is the processing model of these applications, right? Typically user applications, they work in three different ways. One is a simple event-driven application behavior, where any event happens, it wakes up and it performs that activity and sleeps again, right? Then there are typical thread per connection model, where anytime something new connection happens, you spawn a thread, you do the execution and finish it off. And then again, anything happens, you do the execution and finish it off. Now, typical bunch of web servers or different categories of web servers, even the streaming servers, they follow these models, right? Nginx, of course, follows a different model, but Apache and all, they follow this kind of model. And similarly, there is a worker thread model, where some threads are doing the IO and some threads are doing the work, right? Where they can do the whole processing, and it typically also means a pipeline stage model, which you can figure it out, right? Now, let's look at the difference from what user space applications do and what the behavior is at L2, L3, L4 level, right? So till L2, L3 or L4 level, the processing which happens is you come inside, you do some interface lookup, you do some L2 lookup in the MAC, and do a LPM lookup, and then forward it out and do the reverse, and maybe in between some firewalls, right? So the amount of processing which you end up doing in L2, L3, L4 applications, I mean, is a limited finite set of instructions or finite set of steps you do. Right now, it may be oversimplifying it, but to a great extent, model lies to this level, right? Now, but when you go to L4 and above, like above L4, now the possibilities are limitless. Right? The applications might want to very, very different things, right? Some of them, if they are doing a video streaming, there can be, if you are streaming something, let's say India-Pakistan match, I mean, and so many cursors, right? It is a huge streaming and so many connections are getting established, right? Similarly, if you are like doing a file server transfer where the huge downloads are happening, it cannot happen, right? Similarly, let me give you an example. Like we were working on a project for cloud security access broker, where they had to be 10,000 tunnels per server. Now, the moment we reboot the server, those 10,000 SSL connections had to be set up one shot, right? Now, if we follow the standard DPDK model where you have, say, 4 cores and you distribute and each of them do the whole job of getting the connection established, it never happens. It always was timing out and never always timing out, right? So the models which a user space application can follow, they can be very, very different from the way the models currently have been imagined with the L2, L3, L4 applications, right? And these are the basic problems because of which these apps, the user space applications are not able to migrate or utilize the benefit of DPDK and VPP environments. Right? So based on this context, I wanted to highlight some of the key limitations of DPDK for the user space apps. Right? Now, DPDK kind of has a notion that there should be a thread per logical core so that it is closely binded to it and it should only work on that. Now, this is a good model, definitely, because it helps in reducing a lot of contentions. No contentions and work free, you do everything and run to completion, things happen. But again, as I said, the user space applications, they have very, very different needs and different requirements which cannot be bounded into certain n number of fixed steps. And that's where it prevents many applications to follow this model. Now, and again, as I said, if you want to rewrite the applications, maybe we can reimagine how the applications are written and do it, but that is something is not an option in many cases. Right? Now, also let's talk about the DPDK based TCP stacks. Right? So these TCP, like we have a lot of examples, which today in the morning also we discussed. Right? There are like FStack is one of them, MPTCP is one of them, and VPP also, and also the one TNA, I think, which you mentioned, right? So again, many applications which are written from the user space, they use blocking operations, right? And that is typically in the slow path. They also have a slow path, fast path kind of things, but when they're doing their slow path operations, they do a lot of blocking things. Now, once they do blocking operations, these stacks almost become unusable. Right? Or you have to do a lot of hacks to or make it happen, or you change the applications in such a way that they can adapt to that model. Right? Now, if this model has to be adopted, again, a lot of changes have to be done. And if you want to bring the async behavior, it is almost about writing state machines and introducing a lot of changes which require a lot of time. Right? Now, similarly, like there are a lot of user space applications which have a lot of significant dependency on IP tables and NF tables. Right? They want to change the packet behaviors when they're coming to them so that they can tune themselves according to it. Right? Now, similarly, like when you're running these applications, many of them has a dependency on the routing. They understand the routes or the interfaces going up and down and accordingly tune their behavior. Now, many of these stacks, they are majorly driven by the configuration of the interfaces, and that's it. Right? That does not really help in making these applications really real time. Right? You know something, it happened at the time of initializations and it is assumed it remains like that. In some cases, those are true, but in the real world, it doesn't happen. Right? The things will keep on changing and different, and those things have to be adapted for. And it is not a difficult problem to solve also. Like it is more about, it's just about having an integration with Netlink, and you can get the states and make it work. Right? And in fact, none of the things which I've been talking about are difficult problems to solve. It's more about just having a framework where these can be done and this can be enabled. Right? Now, let's take one very simple example which we were doing while we were doing one of the projects. Right? So it was majorly about doing the DPI, let's say, with the SNOT or Suricata kind of interfaces, right? Now, SNOT and in the user space applications, these primary things, they exist as a standalone entity. There's nothing which is kind of binding them together and see that they can work together and provide a unified output. So for example, if I look at SNOT and Suricata, they are very widely deployed, right, as an IPS IDS systems, and they are used well across the places, right? But they expect The packet comes, and then from there we will do the things, whatever we have to do. And which is fair if you're writing a standalone application. Now, if I want to do or if I'm building a security application, so I'm receiving the packets which are encrypted. Now I have to decrypt it, and once I decrypt, I have to give it to Snort so that it can do a DPI. And once it does, it has to come back, and then I have to send it back encrypted via the SSL proxy so that it can go. Now, if I follow these steps, the application performance has gone. It cannot work. And that is where the things happen. So if we have a framework which enables that DPI can happen, which enables that SSL TLS can happen, the proxy can be done, DPI inspections can happen together, that will really solve many of these problems and see that we are able to enhance the throughput of user space applications. Now, this is just about a small thing I did about VPP and DPDK, and I just wanted to say that in many things, VPP has much more and has offered much more to the customers or to the end users to integrate. But still, the key problem is VPP is very difficult to adopt in a general level. But otherwise, it does provide very high throughput. It has provided its host stack. It has provided ways to integrate with the MMF, and also various APIs through which the applications can instantiate it. But that is a way where we can go further, but still there is a lot of things to do. But the complexity of VPP is becoming a bit of a deterrence. Right. So with this, would like to have some vision of how the user space application framework should look like. Okay, and now whatever we are going to say, it is not something. This is right. It is something just our thoughts, and it can always be improved and discussed and see that what is the right way to do, how things can be improved and done in the right way. Right? So the key objectives are to provide a framework so that it can help in building applications, various user space applications in an integrated and efficient manner. Right now, as I mentioned, everything exists in a fragmented way, and that really creates a lot of inefficiencies in the system. Right? So the key thing here is, if we enforce a certain model that, okay, these applications have to run only in this way, I believe that we have already lost the battle. The framework should be in such a way that it should be able to adapt itself or provide that, okay, the certain frameworks should be allowed. Right? Now, enable the application. So, and the other thing should be, these applications should be allowed to capture packets from any particular layer. Whether it will, directly from the interface, it already is there, at a L2 level, at a L3 level, L4 level, TLS level, and also when you inject the packet out wherever you want to do, you should be able to do. Right? And at the same time, there should be connection hooks which are present, so that if you want to alter the behavior or do something in the packet processing path, you are able to do. Right? And similarly, there should be a way to insert connection tables, where the kind of session tables, it can be an RT, these connection tables can be updated to be the RT flow, or it can remain as a table which can do things, but help in optimizing the packet path for most of the times. Right? Similarly, it should always, this framework should have a mechanism where it can pull the state from the control applications and populate the route tables, interface states, addresses, etc. into the system, so that they are always updated and always see the current behavior of the system. And if any actions have to be taken, they can take. Right? And it should always provide an accelerator for the crypto and the TLS and EIML, D-packet inspections, or what can be done. So to some extent, these accelerators already exist, but they again exist in an isolation. But they have to be present in a way where the applications can utilize it in the right way, and then it helps in easing their operations. Right. So this is one way which you're thinking, and this is, as that is just a very high preliminary thoughts what it should be. But if we build a DPDK based frameworks, where we have the DPDK based library, we have the L2 stack, we provide the connection hooks, we have the L3 stack, which provides the whole thing, then we have the L4 stack, and then the connection tables, and they can come at different levels and different frameworks which can be used for different purposes, right? So if we build this kind of framework, then most of the applications should be able to adapt to it, should be able to use it, and be more efficient, and can become more and more, can say, faster than what they are currently is. Right? And this is again what I feel is that how the applications should be, they should have a choice what should be their core execution models. Now if we want that the application should run as a run to completion, we should be having a way to do that. If the application says, no, I have a worker thread model, it should be able to select the packets and do the IO on the worker threads. If it has something else of its requirements, it should be able to do. Right? And let's remember that the number of cores which are there in the system will always be much lesser than number of threads which many high-speed application needs. So by limiting that you can only have number of threads as the number of L cores will be again a big problem and become a deterrent, unless and until the architecture of the applications is improved to a great extent. Right? So it just highlights that there are different cores, and the different cores, what all can be done, and it should be flexible enough where I should be able to choose how I want to run my application, how the application should be built for the system. Right? And the framework should enable that rather than restrict it. Right? So once we do this, right, the key thing is that if we enable support for various connection tables, right, these connection tables can be very, very useful specifically for the proxy apps. So now, and this is how like various even eBPFs have improved their performance. Like for the proxy applications, when a traffic comes, you know what is to be there and where it has to be sent. Once all the slow path has been done, connection has been established. If you set up a connection table, you can forward the traffic very easily, right, without having to do the whole processing again and again. Right? Now, similarly, when you talk about the cloud security brokers, right, typically they have on one side there is a highway, on the other side there are a huge number of users who are connected, and the connections can be of very, very different categories. Some can be on a very low-end connection, some can be high-end connections, and they need special traffic shaping effort. So if that kind of applications are supported, that will really, frameworks are supported, that can help a lot. Right? And as I said, the user space applications, they should be free to or pick up packet from different levels of the stack, either directly from the interface or after the L2 layer, L3 layer, L4 layer, or whatever their need is. And they should be again able to send and receive traffic without the copy operations. Right? As of now, wherever we have the TCP stacks, right, although we say that DPDK has an advantage of zero copy, but unfortunately, as soon as we come to the TCP stacks, that zero copy advantage goes away. Okay? That something should be taken care of to a great extent, and that will really help a lot. Right? And again, there will always be the situations where they will, in the system, there will be other applications will also be running which are non-data path applications. And they can generate some states which can be shared with these user space applications, and the coexistence have to be allowed. Right? And again, the hooks to alter the packet processing behavior. Right. These are the like the netlink support, as I mentioned, that where we are able to understand the state of the system, what is happening, and update the applications with that. And this is about the thread usage model. Again, the framework should be allowing the threads to be set up in different possible ways as much possible. At least we can, if not everything, we can choose 2, 3, 4 models which can bind the things, and then the rest can come later. But at least that way enable the most common application models which are available or which user space applications use. Have those models, and with those models we can do things. And again, as I said, a lot of applications, they use blocking operations. Now, from the data path point of view, yes, blocking operations, they don't make sense. But from the slow path point of view, they are written, and now if you want to change it, it's a big headache. And now, and nobody wants to do that from the simple time to market reasons. And again, simply about retesting the whole effort is a big pain. Okay. The next thing I want to talk about is like DPDK provides crypto framework, but all about the TLS, right? Where the applications can do the handshake, do the complete TLS session, and then build the crypto. That will really help a lot, because right now the various options which are there for like the TLS part, say for example, OpenSSL. Now, OpenSSL library has a lot of limitations with respect to multiprocessing or multi-threading. It does support, it is thread safe, but it takes a lot of locks, and that kills your performance. Similarly, although there are alternates like the Wolf SSL and the Boring SSL, but they also come with some limitations. So while we are building this framework, we should keep in mind that we are building a TLS layer which can give a big boost to the applications, and they can really become quite improved. Now, this is another thing which I wanted to discuss about the granular resource pools. Right? As of now, when we are doing the resource pools, these resource pools are like you have a resource pool, and then you have per CPU cores, right? And then the intention is that the threads which will be there, those will be again per core, and they will not take any locks, right? But such things, they don't again happen when we are using the some of the user space applications. And we were facing we were working on a project where we had to migrate an application, and we wanted to use we wanted to analyze the behavior of how the application is running. So they were having a simple object pool with different cores, and what they were having is a global pool, and they were having per object pool, which is like a cache, right? Now, the intention was anytime any thread comes, it will take from the cache. If it is available, it will take it. Otherwise, it will take from the global pool, right? Now, the global pool again was like some kind of doing mallocs and frees, and they wanted to avoid those things, and that's why those pools were built. But once you're scaling the application, it ended up creating 2,500 threads. And even in the data path, the key problem was they were using SSL, and in the SSL, they were doing a lot of packet multiplexing. So let's say when from one end to other end, when it is coming, they were tying up to 100 frames in a single packet. And once it comes on the other side, untie those frames, create a copy, and then kind of allocate, create a copy of those individual packets within the same frame, and then process them. So in their fast path, their allocation frees were too many. And if they had to do that, and the amount of contention which they had because of this was very, very high. Because every packet of the frame they are receiving, it has internally 100 packets, and they have to copy those packets. So they had to do mallocs or the buffer pools, copy it, and then process it. So this was really kind of getting messy, and then we kind of created smaller pools per object, and which are like per tunnel. So that way we had to really, we could solve the contention to a great extent, and we could improve the performance by about 4 to 2 to 3 times, right? And that really helped so much. So that's why I thought it might be good to have this granular resource pool as a concept even in DPDK. Right? And similarly, like all these applications today, they need session export, they need telemetry, they need session state management, but the amount of support which the DPDK as a framework has for these things is very, very minimal, right? So these are the key things, and then I just wanted to highlight that how the applications can be benefited if they use this proposed framework, right? So currently when these applications are used, let's take an example, this proxy application, right? So the kernel, it receives the packets IP and the kernel TCP IP stack, and then here the OpenSSL library runs in the user space, and then it receives the packet, and then it figures out who is the peer, it goes to that, comes out and sends a packet, right? The whole thing. Now, if this whole process happens like this, where during the slow path it decides, but then it sets up the connection table with the both sides tunnel entries and what are the keys and the connection which has been established. Directly the packets can go from here to here and no need even to come. So whatever the fast path, slow path concepts we apply, those concepts can start coming to the user space applications, and they can help a lot. Right? Similarly, this is about what I told about the granular resource. This something is like where we created multiple granular resource and improved the performance by almost 2 to 3 times by reducing the contentions. Okay. So yeah, I mean, coming to the next steps, would say is what we feel is there is really a very strong need to build this DPDK framework, and would like to request to the community to take this up. And if there is anything needed, if these are the very genuine problems or some things which should be solved, and if something needs to be done to make it happen, we're willing to like help and contribute in that as well. Okay, I think that brings me to the end of this session. Any questions?
Any questions for Vivek?
Yeah.
So you mentioned about per thread resource is not, I mean, grouping is not supported, like our fine-grained resource management, let's say mempool, right?
Yes.
So DPDK supports basically like...
It supports at a level where you have an object caches, right? So what it will, you have a global mempool, and then what you have a cache. And the cache at a per core level.
But that is actually at a thread level, because you can, I mean, it supports multiple threads mapping to a single core.
But then you will have to take a lock. If you want to make it lockless, then you will not, because if you want if each thread is mapped, you map a thread to a core, right? And then it remains lockless as long as there is no other guy contending for that.
I think internally, like, I mean, what it says is L core, not physical core.
I'm talking about L core.
L core, yeah.
Yeah, I'm talking about L core.
Okay, so at least you like, you can have this per L core level caching. So basically, like, by sizing that per L core level cache, you will be able to, like, you don't have to go to the global mempool every time.
Yeah.
Yes, okay.
So that is already there.
Okay.
That is already supported. Now the point is, if I want to have 2,500 threads, right? I cannot have those many cores, right? So what I will need to have is, multiple threads which are running on the same core. Then I will again having the logs. And I'm again having the logs and the contention. The whole purpose of caching is lost. Right?
Okay.
So instead, if I, let's say, have a granular resource, let's say I say that I need a pool per tunnel, for example. If there are 2,500 tunnels, I can say, can I create a pool per tunnel, right? So the number of resources which I need almost remain the same. Now those resources, those pools can be micro pools. which are very, very minimal resources there. But the contentions in them is drastically reduced.
Yeah, so the problem it will bring is about resource utilization, resource management, right? So you will have, at any scenario, you will have basically with multiple pools, you will have certain pools which are starving for resources, certain pools which are not unutilized resources.
Yeah, see, that still happens, even if you have per core resources, right? Yeah.
I think what Shiva is trying to highlight is mempool can be configured in the default mode as ring mode, where you have per object. There's another mode wherein which when you create mempool, you can tell I want to have stacked model.
Correct.
In stack model, what it does internally is that each object that you use is put back into the local cache only.
Correct.
It is not.
Yes,
It is not the split one.
Correct,
So
correct.
from that angle, if this framework or if the logic had used stack pool, have you done the analysis?
Yes. That is how we did. See, the point, what I'm trying to say is each cache when you create, it is a ring as you mentioned, right? So when you free up the resource, it goes into that particular pool itself, and then it can be recycled. But the point is, this holds well if there is only a single thread which is looking at for that particular core, and then you can free it. If the multiple threads are doing it, and the number of threads are too many, then again the contention will happen.
Okay. The other thing is, I mean, like, I think the requirement, that I think all the challenges, right? So that results into a requirement about making DPDK as a service rather than as, leaving it as a library. Is that what you're looking at?
No, it can remain not as a service, because then everything will be running all the time.
Yeah.
That is not what is needed. Then the applications will become bloated. It should be a framework where the application can choose to init what it wants. Because otherwise, if everything is running, then it becomes bloated and the whole project.
Yeah, it is the same thing like
Yes,
VPP,
that
but again, the same problems that we have.
We
with
don't.
VPP.
That should not be the case.
Okay.
It should be a library which the application can choose to initialize if it needs to. If it doesn't need, that's fine.
Okay, thank you.
Okay.
Any other questions?
Thank you for your compiled list of these proposals based on your customer requirement, as you stated.
Yes.
So I like to confirm one of your customer requirement, which is I think very basic.
Which one you want to go?
You said that there should be a framework or basically a glue layer on the DPDK framework which can enable any open source or user application to migrate on DPDK easily, right? So, for example, let's say there is one application, customer is coming with a requirement that there is one application which is running with kernel environment as of now and giving 1 Gbps of throughput. And when the same application running with the VPP stack, for example, okay, or within the VPP basically, it is giving 5 Gbps performance. So when they are asking for this particular requirement that please migrate this application to DPDK, don't want to use VPP. So what is their performance expectation? They are expecting same 5 Gbps or something between 1 to 5?
I think there is a fundamental flaw here. See, if somebody is already running the application with VPP, the chances that they will ask us to move to DPDK are very, very less. But if somebody is running on just directly on the standard Linux kernel environment, they would ask us to move to the VPP or DPDK, which is fine. But if somebody has already migrated to VPP, then the chances of that happening will be.
I'm not saying they have already migrated. So, for example, the similar thing is available in the VPP, and they have taken their performance as a target.
Okay.
So, what is their mindset? They are expecting somewhat between 1 to 5 Gbps when their application migrating, or exactly around 5 Gbps only, because they have seen VPP to work as a 5 Gbps.
That is based on what happens is once they give us the application, right? We have to analyze what that application is doing, and based on that application, what it needs to migrate it to the VPP or a DPDK, and what kind of time and effort it is going to take.
That's
right? Of course, right?
That's
and
a different
based
thing.
on that, they make a choice, right?
But that's a different thing. But let's say they are saying that our application is fully optimized. Very good. So what is their expectation then? They will migrate to DPDK and they will get 5 Gbps?
Yeah, they would expect.
But I think there is a problem, practical problem, that they will not, in my understanding, because what you are proposing here is to have multiple threads on the same core. You are proposing that they have
No, I'm saying, what I'm saying that is, in case the application has a model where they want to have so many worker threads.
Right.
In that case, in case it can be mapped to with a thread per core, then go with that.
Okay.
Right? But that should be a flexibility available with the system, which way I can map my applications.
What I'm saying is, if you have a multiple thread on a same core, they're going to be context switching. When there is a context switching, there is a TLB thrashing, there is a cache invalidation involved. That means you will never going to get that performance. That's why DPDK has
it
a
can
single
be-
thread
yes,
model on the same
yes,
core.
correct.
So
That
that means
is-
they have a clear expectation that they are not going to get the 5 GPS, they are going to get less. If
See,
there is a glue layer
okay.
introduced in between, which enable them to migrate their application easily.
Correct. See,
Okay.
that will always be the case. See, basically, what I'm trying to say is that something has to be explained to them, what is it? They will come with that, okay, I want, can I move to 5 Gbps? But then this has, what you exactly say is very true. That is what should happen. And ultimately, that has to be said that, okay, because of these reason, it may or may not happen. But at least from 1 Gbps, they can land something in 3 to 4 Gbps
Yes.
range.
That I
And
said,
which is
something
fine.
better than kernel.
Correct.
Okay,
Yes.
got it.
So my question is about the performance numbers. So I'm just curious to know, based on your experience, like with the top tier smart NICs with some kind of cryptographic like TLS inline acceleration, what is the possible performance for like IPsec or VPN with TLS
See,
that we
as I said,
can possibly achieve today?
See, I said, I'll tell you what I have seen, but those are in pretty low-end environments. And those environments, the comparison is if I have a 10 gig line rate PC, right? My line rate will be 10 Mbps. With IPsec, I can get 7 to 8 Gbps. And with if I use OpenVPN or Soft Ether, it can become to 2 Gbps.
That number, are you using smart NIC with crypto
Standard.
acceleration?
It is with using the, it's an Intel NIC, and for OpenVPN, it typically is using the ASNI instructions. And for the IPsec, it is using the standard kernel crypto framework.
Okay, thank you.
Hi,
Hey.
I have a similar question to what he asked.
Yes.
I mean, have you done any analysis of at what point after you've added all your desired features to DPDK, would you come to a conclusion that whether there's any performance advantage left for using DPDK in the first place, right? So if you keep moving DPDK in a direction where it becomes really general purpose,
I mean, okay, so but your point is that, okay, it will become the same state as what is there written.
right?
I don't think so. The reasons being, first of all, you are avoiding a lot of copy operations, okay, which the user applications do it. And you are having a complete integrated framework where today if one application wants to use another service, there again it has to divert the traffic to the other guy, and it really kills the things. So yes, there will be penalties, and your fear is really true. I mean, I don't deny it, because everything starts with some good intentions, but it ultimately keeps on adding feature creep. But it should not happen that the applications, they have to keep on suffering. Because people have that need where they want to do it. If you think DPDK not, then maybe if there is some other way to do it, that is also fine. But
Another quick question. So you were dismissive of VPP as an option. You're saying it's too bloated, or
this has been the feedback which we are getting from our customers many times. VPP has very good advantages because it has built a complete stack. Right? It has built the IP, it has built the L4, and then it has also done the TLS. But in general, the complexity of VPP in adopting the applications is kind of what I am seeing as a jitter. The customers want to avoid it, because what they always say is that once the certain applications have been migrated, they should be in a state where they can maintain it themselves. And they feel that it may not happen. That is where they say that they feel DPDK as a framework is much simpler to use as compared to what VPP provides. But yeah.
This is not a question, it's a small add-on to
Yeah,
our
sure.
friend's comment there. it's not DPDK application, just to clarify.
Yeah.
What at least from my perspective, what DPDK helped to bring in was a standard vendor agnostic way of getting high performance libraries.
Yes.
It is not an application, first point.
Yes, yes.
Now, coming back to a point that was suggested, at what point will we decide that all this layering, I call this layering.
But you're not, sorry to
Please, please.
Yeah. Basically, these are just individual piece of frameworks, and the application can choose to enable that or not. So it will not always come in the path or do that. But yes,
So-
those code will of course be there.
Correct. So
Yes.
just to put it, just like DPDK graph nodes, VPPs,
VPPs plugins, yes.
VLib processing layer, there is a standard framework. Okay, do prefetch XYZ, do ABCD, if you have Dion or SIMD, do ABCD comparison and all. This is a suggestion.
Correct.
Good idea. Now, based on the suggestion, just 1 month back, I was looking at a software code that was written for doing packet processing and UPF. Now, in that, all these things were, as per the framework they wrote it, as per the BTune, Emon tools and all, whatever it told, they wrote it very nicely. They ended up in SMT contention. They ended up in backend contention, register reordering problems and all. But when a vendor writes a PMD library and all, they fine-tune those things to prevent from this happening. So, from my experience, at least when you break it up, you add some bigger problems which are not foreseen. So, yes, idea is good in terms of layering, but as you keep on increasing the layers or activate the layers, many unforeseen problems
will come.
from the hardware perspective pops up. So, just to add, that's all. Thank you.
Yeah, thank you. Your extensive talk brings a lot of discussion, that's clear. Unfortunately, we are really late on the planning. And it makes me remember that when we did the planning of this day, we planned to have your talk at last because it was supposed to bring a lot of discussion.
Okay.
So I'm very glad to see that I was right on that. So what I propose is to continue discussion during the reception, etc.
Sure.
If you all agree.
Absolutely, yeah.
So, okay? Is there any specific, very important question? No. We'll continue. There are a lot of to say.
Yeah, thank you.